This is unit number 6, video number 4, heat capacity, or we could say specific heat capacity since we're going to be working with mass. The specific heat capacity is the tendency of a substance to heat up. We all know metals heat up really quick. Something like water seems to take a really long time to heat up. That's because water has a very high heat capacity, meaning it takes a lot of energy to change its temperature. Whereas a metal rod, say an iron rod, has a very low heat capacity. It takes very little heat to change the temperature of it. So you know it'll heat and cool relatively fast. So the equation for specific heat capacity is the specific heat is equal to the heat. We're going to use letter Q to represent the heat, divided by the mass and the temperature change the substance undergoes. Or an easier way to write it is that the heat is equal to the specific heat times the mass times the temperature change. Okay? Got a couple examples here. Let's calculate the mass of aluminum present. If 1,015 joules, and that's going to be our unit of heat, we could use calories, but we're going to use joules. 1,015 joules of heat changes the temperature from 25 to 75 degrees Celsius. To do this calculation, we have to have the specific heat. That's a known value. It comes out of tables. The specific heat of aluminum is 0.9 joules per gram degree Celsius. So I'm going to solve for the mass. So I know Q equals SM delta T. So let's plug those in. I've got 1,015 joules equals the specific heat, which is 0.900 joules per gram degree Celsius, times the mass, which is unknown, so we use the letter M to represent the mass, times the temperature change, which is final minus initial, 75.0 minus 25.0. Okay? So here we've got 25, so the mass is going to be equal to, I'm going to remove the units, 1015 divided by 0.90 times 50. And that equals 22.6 grams. So we would have 22.6 grams of aluminum present if this much heat was used to change it by 50 degrees. Okay? Let's calculate another one. What is the specific heat of silver if 472 joules changes 10 grams from 25 to 222 degrees Celsius? Well, now we're calculating the specific heat. We know Q equals SM delta T. So the specific heat is going to be equal to the heat divided by the mass and the change in temperature. Let's just plug our numbers in. We have 472 joules. So I'm going to have 472 joules is the heat. That's Q. Equals the specific heat of silver. That's our unknown. Times the mass, which is 10 grams, times the temperature change, final minus initial, 222 minus 25.0, that's going to equal, or we can rewrite that, and solve for the specific heat. So the specific heat is going to equal 0.240 joules per gram degree Celsius. So the specific heat is the heat necessary to change the temperature of a substance. Obviously, it's mass dependent. The more mass, the more heat is going to be necessary to change its temperature. Not just going up, we can talk about it cooling as well.